Hello, my name is Namaki Biswas. My student number is 101338276 and this is my final project for EGN5208 databases for software engineers. I have built a health and fitness club management system using PostgreSQL as the database, Python Flask for the backend REST API, and React with Tailwind CSS for the front end. The system supports 3 user roles: members, trainers, and administrative staff, and each with role-specific operation. In total, there are exactly 8 operations. I will show you the database design first, then demonstrate the application interface and execution flow from the web UI through the backend API to the PostgreSQL database. Let me start by walking through the database design first. So, here is my entity relationship diagram. The system has 13 entities. The core entities are member, the clients of the fitness club with attributes like name, email, date of birth, gender, and phone number. And the trainer, the staff who provide the training services, and the admin who are the administrative staff who manage the operations. And here is the room for the physical spaces in the club, and the equipment is for gym equipment, each associated with a room. Supporting entities include the fitness goal, and targets are set by the members like target weight, and health metric appends only the health records like weight, heart rate, etc. with timestamps. Now the trainer availability. So the time slots when the trainers are available. Now the personal session is for one-to-one training sessions linking a member, trainer, and a room. And there is a group class which is for the group fitness classes with a trainer and room. And the class enrollment. So here this is the junction table for the many-to-many relationship between the members and group classes. And the equipment maintenance is here, which is the maintenance logs for equipment and the payment records for the members. Now the key relationships is a member can have many health metrics and many fitness goals, both one-to-many. And a trainer can have the availability slots and conducts many personal sessions, which is one-to-many. And members and group classes have a many-to-many relationship through class enrollment. Here we can see that. And the equipment belongs to a room, which is many-to-many. And the equipment can have many maintenance records, like one-to-many. Now the participation constraints are the personal sessions, group classes, and class enrollments require exactly one member, trainer, or room. Total participation. So the members, trainers, and rooms can exist without any sessions. That means partial participation. Now the ER model plays a central role in the system design, and it defines the entities, attributes, and relationships that the database schema and application are built around. This model directly supports all 8 required operations. For an example, the health metric entity supports the operation 2, 3, 4, and the room and personal sessions support the operation 7. So here is the relational schema, and it has a direct correspondence to the ER model that I showed before. And each entity maps to the table, and each relationship maps to the foreign keys or junction tables. You can see the primary keys are underlined here, and the foreign keys are marked with arrows connecting the tables. You can trace every table back to its entity in the ER diagram. For an example, the personal session. That means here the personal session table has foreign keys referencing the member, trainer, and room. The class enrollment table serves as the junction table for many-to-many relationship, and it has the foreign keys to both member and group class. And the equipment table here, the equipment table has the foreign key to room representing which room the equipment is in, and the health metric references is showing that each metric belongs to one member. So regarding the normalization, all tables satisfy the first, second, and third normal form. So in one NF, every attribute contains only one atomic values, no repeating groups, and each table has the defined primary key. And in 2NF, all non-key attributes are fully functionally dependent on the entire primary key with single column surrogates keys, and the partial dependencies are impossible. So the class enrollment uses a unique constraint on class ID and member ID. In 3NF, there are no transitive dependencies. Non-key attributes do not depend on the other non-key attributes. For an example, in the member table, here in the member table, the attributes name, email, phone, date of birth, and gender all depend solely on member ID. None of them determine each other. No derived attributes. Age is computed from date of birth at query time, and total classes attended and upcoming sessions count are computed via queries, not stored. Now the health metric design. The health metric table uses the white table design. Here, that is the columns for the weight, body fat, PCT, blood pressure, heart rate, rather than an EAV pattern with metric type and metric value. The metric types are fixed and known, and each record captures multiple measurements at one timestamp, and each simplifies the dashboard aggregation. Now the design decision I have used is 3 separate tables for member, trainer, and admin instead of a single user table. Each role has distinct attributes, and the trainers have specialization. Members have date of birth and gender, which avoids the null columns and keeps the foreign keys references clear. Now let me show you my detail file. Let me show the keywords. So you can see the table definitions with proper constraints here. Not null on required fields and unique on email addresses. Check constraints for valid values and foreign keys with appropriate references. Now let me show you the view. So here's my view, member dashboard view. It aggregates the data from member, health metric, fitness goal, personal session, and class enrollment using the lateral joins. So this provides the consolidated summary for the dashboard operation in one query. Now let's talk about the triggers, and here let's search for it. Okay, so I have 7 trigger functions covering 10 triggers. The main one is room double booking prevention, and before a personal session or group class is inserted or updated, it checks whether the room is already booked for an overlapping time. Other triggers prevent and member overlapping sessions, trainer double checking, full class over enrollment, health metric updates or deletes, enforcing the app and only history. So overlapping trainer availability and verifying the trainer has an availability slot before a session can be booked. Now let me show you the indexes. Here you can see the DML file loads the realistic sample data here, and the members, trainers, admins, rooms, equipment, availability slot, sessions, classes, enrollments, and maintenance records. These data is sufficient to test all the 8 operations. Now let me show you my backend routes member py file. So here the application uses raw SQL, no ORM. So each route executes the parameterized queries via psychopeek to prevent SQL injection. I also have stored functions in the database, which is fn So here you can see the FN check booking. FN check booking. mm, check booking conflicts that returns the conflict details when a booking fails. So the application can show you why and when a slot is unavailable. In the FN trainer slot booking status, it enriches the availability slots with the existing bookings for the calendar UI. Now, let's talk about the all 8 operations and its success and failure cases. So the operation 1 is user registration from the member end. Now I will register a new member, and the execution flow is I fill the form in the web interface and the front end sends a post request to the backend API, and the backend executes an insert statements against the member table in PostgreSQL. So before walking through this one, I want to show you an interesting part that I can enable the dark mode here, but I will show the demo in light mode because I like it. Okay, now let's create account. For an example, I will give the name John Dan, and the email address from suppose one merge. 615 and 5014, and password. Now I will try to create the account here. Let's see what happens. Okay, so the registration is successful. The member was created successfully. So the registration timestamp is also stored automatically by the database. Now let's try for the failure case. I will try to register again with the same email address. Let's see what happens now again. So I will go to the register page again and we'll try to do the same. Let's see if it can give me the error message. Same email address, birth year, 613, 5. Okay. Now let's see what happens. See, an account, I received an error message, an account with this email already exists. So the system rejects the registration with clear error message, that is email already registered, that we already saw you. And this is basically enforced by the unique constraint on the email column in the member table. Now I want to show you my OpPy file and the query for the registration. So here I have put I insert into member name, email, date of birth, gender, phone, password, hash. So here this query is for the registration. So now I want to show you the operation 2, that is profile management from the member end. So now I will try to log in as a member. So I will go here as sign in. So the Alice is a member. Now I will sign in here and will directly go to the profile, and here I want to change her phone number. So this executes an update statement on the member table if I can update the change here. So let's see if I can do that. Suppose 851. Okay, now I want to save the changes. Now let's see. Okay, so the profile is updated successfully. Cool. Now I want to show you the health and goals pages here, where I can add, you can see I can add the goals and the record matrix here. So let me show you how I can add a goal. Suppose my goal is to make 75 weight, and which is starting from tomorrow and ending is suppose 19. Okay, so this is basically an insert into the fitness goal table. Now let's see what happens here. Okay, so here I can see that it is added here to the 75. Okay, so I could add the goal here successfully. Now I want to show you how would I add a metric here. So if I put the weight, for an example, 85. And now I will record the metric. Let's see. Okay, so the metric is recorded here. You can see the health metric is recorded here with the current timestamp. here. So health metrics are append only. Existing records are never overwritten or deleted. So for the failure case, I will try to submit or make metric where I won't fill up the required fields. Suppose I need to fill up those, but I'm not gonna do that. Let's see if the system can give the validation error. Let's see. So yes, I could not submit it because it's giving me the validation error here. So now I want to show you the operation 3, that is health history. So in my health and goals page, I can see it displays all the LIS's health metric here. You can see here. So each record shows here the metric type, like body fat, blood pressure, heart rate, weight, and also with the timestamp. So the results are sorted by timestamp and with the most recent first. So I can show you if I add a new metric here, and it will show at the top. So let's see if I can do that. Suppose my weight is I want okay 72. Okay, then 20 is to weight 120 and 80. Heart rate suppose 50. Now I will add a new metric here. Let's see. Metric is recorded, so it should be visible in health record. So yes, so at the topmost I can see the latest metric that I just added here. So here this uses a select query with where to filter by member and order by to sort by timestamp. So now I will show you a failure case here, because if a member has no health records, then the system displays a no records found message instead of an empty table. So I could demonstrate you by logging in as a member, which I just registered here in front of you. So now I will sign in as the new member who has no health record yet. So John Den, I just showed you. So I can sign in with John Den now, who has no health record here. Now it will show that is weight 000. So basically there is no record here. So now I will talk about the operation 4, that is the member dashboard. So as you can see, I have logged in as a member allies. So now I will go to the dashboard here. Here this shows a summary for the logged in member. That means it is showing the Alice Johnson's health records here. We can see that the latest weight is here, 72 kg, active goals, upcoming sessions, and the latest heart rate is also mentioned here. And also below you can see the active goals here, the weight loss, flexibility, endurance, muscle gain. So, and another thing is from here I can see the next session and the next class with the date, time, and who will be the trainer and what is the room number, the timing. So everything is mentioned here. So this basically uses select with joins across the personal session and trainer tables. And for failure cases, now I want to show you if for a new member with no data, the dashboard will show the empty section and the query still run correctly and return no rows. So now I will show you with the new member that I just registered. You saw that. So let's see for him how the dashboard looks like. So that dashboard looks like this. So there is no upcoming sessions, no upcoming classes, no active goals. So everything is 00 and no records are here. Yes. Now I want to show you the operation 5, that is setting availability from the trainer sense. And Frank is the trainer here, and I will select trainer from here and I will log in as a trainer. So Frank Miller is a trainer, so I will try to set an availability for her. So I will go to the availability section and we'll add a time slot here. Let's see, for 11 March 12 p.m. and then up to suppose 1 p.m. Okay, now I will try to add this slot. So the slot is added here. Here you can see that from 12 here in March 11 it's set it here as 12 to 13, so that means 12 to 1 p.m. here. So basically that executes a select to check for overlaps, then an insert. Now I will show you the failure case and I will try to add an overlapping slot for the same date. For an example, that is enrolled here for March 11, 12, 13. So I will give the same. Let's see, 12 p.m. and then 1 p.m. Same date, same timing. Let's see if it can detect it. So this time slot overlaps with an existing availability slot, so the system rejects it with an error. This is enforced by a trigger that checks for time conflicts before inserting. Now I want to show you the operation 6, that is schedule view from the trainer end. So this is Frank Miller, he's a trainer, and the schedule page, we can see that the upcoming group classes and the upcoming personalizations are listed here with date, time, and member and room. And in the upcoming group classes, we can see it is listed by class name, date, time, room, and the enrolled section. So only future sessions are shown and results are sorted by date and start time. So these uses select with joins across personal session, group class, member, and room tables. So now I want to show you a failure case here as well. So I want to log in with a new trainer who has no bookings, no personal sessions, no group classes yet. So let's see how the page looks like. So if everything is okay, then it will show that yeah, you don't have any personal sessions or upcoming group classes yet. So let's sign up from here, and I have registered for a trainer here. So he's a new trainer. Let's see what sees in the dashboard from the Dana. So if I go to the schedule page, see I can see the no upcoming personalizations, no upcoming group classes, no member data is available. So the query correctly returns no rows, and that was the scenario. Perfect. Now I'm talking about the operation 7, that is room booking from the admin end. So here EV is the admin, so I will select the role admin from here and will sign in. And here I can see the admin dashboard, and from here I will try to assign a room for a session. So from room booking I will select Bob Smith and the trainer Frank Miller, and for room I will select the cardio room and the date would be, so here you can see that the availability is here. So I was thinking that to make the user friendly system, so I prefer to show the trainer's availability here. So I can choose it directly from here like this, or I can manually input this. So I will show you that by the manually as well. So now I have just automatically selected it, and here it shows me that the room booking is from March 12, 10 to 2 p.m. So I will select main gym room. Now I will book the session March 12, 10 to, okay. So here I see the session is perfectly booked, and in March 12, 10 to, see that this one I just added, see here, so it's sorted by the date. And so here you can see that. So now I will try to do a failure case here. So I will try to overlap the timing. That's why I do the member, suppose Carol, and the trainer will be the same. And here already is showing though, but still I will try to manually input this to make the conflict timing. So I will select the main Zoom room and select the March 12 and 10 a.m. 10 a.m. to 10 to 2, right? Okay, so 2 p.m. So this availability I will check if it shows me error message. Okay, selecting the room, See, here I got the error message. The train is already booked on 12:10 to 2 p.m. Please choose a different time. So basically the system rejects it with a conflict error, and the application uses if and check booking conflicts to show why and when. And here the room is already booked, so the room double check. So the room basically double booking trigger in the DDL enforces these at the database level. So now I will show you. The admin pie is here, so I will show you from here that the room booking, when I am assigning a room to a member, so this room booking session API is calling from here, and when the system rejects because of the conflict, so that means it's usually it's calling from the FN check booking conflicts. For this API call, the system understands the conflicts error, so then it gives the error message here. So the operation 8, which is equipment maintenance from the admin end. So as I said, if it's the admin, I will sign in from her end, then we'll show you from the equipment page. So in the equipment page, I can view all the equipment in the club. Like equipment maintenance logs are in a separate equipment maintenance table. A design choice that allows multiple issues per equipment and tracks the issue life cycle. So here in the equipment list, you can see that each equipment is associated with a room, and now I will log a new maintenance issue for this treadmill. So for this treadmill, let's go here, and the issue description I can see like repair needed, and I will log the issue now. So the issue is logged here. Okay, now you can see from the maintenance logs it's already here that repair needed. Now from the status I can change it from in progress or resolved, or from here I can also change it to under repair, and for the out of service, like under repair, like I can change the action from here. So if I want to see just the under repair equipments, I can filter it from here as well. So it will just show the equipments that needs that the status are the under repair status. So I can filter it out from here, which are operational, which are not, and I can view the all from here as well. So here all the items currently under repair or out of service, so these uses a select with a where clause filtering by status. So now in failure case, if I try to log a maintenance issue without required fields like the description, then the system will reject it. So let's see if I can do that really. So for leg press machine, I will try to log the issue without filling this required section. Let's see if I can do that. So yes, it does not let me to log the issue here, because you see here, you please fill this field. So the system rejects the request here. Now let's move on to the role-based access control. So here, first of all, I will log in as Alice, who is a member. From here, if I sign in here, I can see that I cannot see any trainer dashboard or admin dashboard from here. And if I try to manually change this, if I want to access, suppose I want to change it to trainer. So what can I do now? So I will write it here as trainer dashboard. Then the system redirects me back. So the access is denied. Role-based access is enforced in two places, and on the backend using the JWT role decorators that checks the user's role before processing any request, and on the front end using protected route components that prevent navigation to unauthorized pages. And here is my error py file. So here there are structured codes for handling the errors. So in PostgreSQL, trigger exceptions are mapped to user-friendly messages via parse db error, and the frontend displays them as toast notifications, as you saw in the failure cases. Okay. Now, finally, I want to talk about the code structure. Here is my project structure here. So in the backend file that you can see, in the routes, this backend folder contains the Flask API, and it is organized into route files like by role, like auth. So in the routes, if I click on in that, so I can see the authorization py, where all the authorization actions are applied here, and then in the members, so all the actions related with the members is included here, and in the trainer the same goes for the trainer as well, so all the trainer related actions are implemented here. Now let's talk about the SQL folder here. So in the SQL folder, you can see that I have the ddl.sql, dml.sql, and role-based access control SQL file is here also included. So then I organized it as the in the front-end folder. In the front-end folder, it contains the React applications with pages organized by the role. So here you can see the index and in the source file you can see the pages API. So in the pages, all the member, trainer, admins pages are maintained here, and in the API, so all the API actions are called from this file. And yes, and then the interesting thing is for the theme. In my starting of the demo, I showed you that I have implemented the light and dark mode theme. So all the theme related implementation is here, so like dark mode, light mode. And finally, if I go to my docs file, I have already discussed about my ER diagram, project report, and the relation schema diagram. So these are organized here in the docs file. So basically the entire project can be set up with a single command that I can show you from here. Okay, so it's hidden from my picture, but okay, so I will mention it here. You can set up this with a single command, that is /start.sh, which installs the PostgreSQL and creates the database and loads the schema and sample data and starts both the backend and front-end server. But if you want to do it specifically, if you want to check the front end and back end, and there is also a command for the back end checking and for the front end side. So, and if I talk about the testing section, I will say that I have tested 225 backend tests, and it all has passed. And in the front end test, I approximately tested 800 plus, and with 100% backend coverage. So GitHub Actions CI pipeline runs on every push. And if I say about my challenges, four main ones. First is the PostgreSQL trigger error messages, which are opaque, and I wrote the parse db error with regex patterns to extract the dates, times, and conflicts types. Secondly, the room double booking had to check both personal session and the group class in one trigger. And third, I would say that when a booking fails, is users need to know why. Member busy, trainer busy, or room busy, and when. So in the fn check booking conflicts that I showed you before, it stored the function returns that detail for the app to show. And finally, the fourth one is the append only health metrics required coordination between the database trigger that blocks the update or delete and the application layer handling those errors gracefully. So, to summarize, all the 8 operations are implemented here. Each interacts with PostgreSQL database using raw SQL in the backend, and both success and failure cases are demonstrated. The database uses views, triggers, stored function, and indexes as required. The application interface guides users through each operation with a clear execution flow. Thank you for watching. Thank you for your patience. Thank you very much.